So this is the start of chapter 12. It's going to be all about solutions and molarity. So we're going to talk about how when you mix a solid and a liquid together, you make a solution, and how to quantify the concentration. So to start with, a solution is a homogeneous mixture of two or more substances. That means they're uniformly dispersed in a single phase. So it all looks like one uniform substance. So when you mix salt and water together, it looks like it turns into one uniform substance. As opposed to mixing sand and water, you can see the sand floating around in the water. It does not look uniform. It's typically a solid dissolved in liquid. Sometimes you can have a metal dissolved in another metal. That is called an alloy. But we're going to focus this unit on solids that are dissolved in liquids. So the word soluble means that a substance is capable of being dissolved. We talked about this in chapter 8 when we put AQ or S behind each compound. We decided whether it was soluble or not. So that just means it's capable of being dissolved. So salt is capable of being dissolved. We'd say salt is soluble. But we'd say sand is insoluble or sand is not soluble. And another thing that I want to point out here is that like dissolves like. So what does that mean? If you remember way back when we talked about polar compounds, nonpolar compounds, covalent compounds, and ionic compounds, we didn't really talk too much about polar and nonpolar, but polar compounds have partial charges and nonpolar compounds are very neutral. What you need to know is that polar compounds like to interact with other polar compounds, and nonpolar compounds like to react with other nonpolar compounds. That's why, here we'll move on here. If you get a mixture of oil and water, the reason they don't mix is because oil is very nonpolar and water is very polar. So they don't really like to interact or mix. They tend to separate and stay in their individual layers. So it's just something to keep in mind. Here it says which one's polar and which one's nonpolar. So just know that like dissolves like. These two things are not like each other. One is nonpolar, one is polar. Okay, some other definitions to know. When you dissolve something in water, the thing that is being dissolved, or when you dissolve something in anything else, the thing that is being dissolved is called the solute. That is what is being dissolved. Typically a solid. Okay, then on the other hand here, the solvent is the thing that does the dissolving. That's what the solute is dissolved in. So that is typically water. In our class, we're going to only be using water as our solvent. So if we're looking at our picture over here, this would be the solute, and then the water down here is the solvent. So just make sure you're aware of those terms. Now some characteristics of solutions. They're transparent. That means that light passes through them. So you can see down here, you can see through these solutions. They do not look cloudy. Light passes through them. Everything I just said. It will also never settle out. So if you leave this solution, you'll never have, let's say this is copper sulfate. Copper sulfate's blue. You'll never have the copper sulfate settle out, and you'll never see the copper sulfate on the bottom. It will always stay mixed forever and ever, as long as the water doesn't evaporate away. And it's a uniform composition. It's the same everywhere. Suspensions, on the other hand, they're technically not dissolved. So if you got like sand in a jar here with water, if you mix it up, at first you'll have a suspension here. The sand particles are not dissolved, so you know that because the light does not pass through the mixture. It's got a larger particle size, and it will settle over time. So you can see if you wait, it gets darker on the bottom, and then eventually the sand will settle out if you wait long enough. And it is not uniform, as it says up here. It is heterogeneous. And it can be separated by filtration. And here's another cool example of a precipitate reaction where you got a suspension. You can see it settling out. Colloids. So colloids are a little bit smaller particles than suspensions, which makes a difference. But they are bigger than in solution, so colloids don't necessarily settle out. So if you see this jar full of sand, silt, clay, the sand, if you were to shake this up, the sand would initially be mixed in, you'd have a suspension. But the sand would settle out, the silt would settle out, the clay settle. Sorry, I got interrupted there. So as I was saying, the sand would settle out, the silt would settle out, the clay would eventually settle out. Now, clay is made up of different sized particles. Some of the heavier ones will settle out, but then some of the smaller ones will actually stay floating in solution. They're still not dissolved, but they won't settle out. They're a little too small, so it will stay murky looking for forever and ever. It won't settle. Let's see here. They are also heterogeneous, and that's where we're at with colloids. So just know the different properties of those different mixtures, a solution, colloid, and suspension. We've actually already touched on this one as well, electrolytes. So when you think of electrolyte, you probably think of Gatorade or sports drinks. It's a substance that conducts electricity when dissolved in water. Now sometimes I forget to do this demo earlier in the year, but I mixed the salt with water, then I mixed the sugar with water, and we had that light bulb with the two wires. If the substance dissolves and it's ionic, it tends to conduct electricity. If it's covalent, it doesn't conduct electricity. So you actually saw that demo already, but that's electrolytes are usually ionic compounds that are dissolved in water. So just know if it conducts electricity when dissolved, it's an electrolyte. If it doesn't conduct electricity, that's called a non-electrolyte. So that would be something like sugar or any other covalent compound that dissolves in water. And again, you hear about electrolytes all the time. You got a whole bunch of them here. Calcium, magnesium, manganese, sodium. Typically, you probably think of like sodium, chlorine, potassium, because if you work out rigorously, your sweat contains a lot of these electrolytes. So if you lose these electrolytes through your sweat and you just drink plain water, eventually your body will get diluted, and if you don't have enough electrolytes, bad things can happen because your nerve cells use these electrolytes to conduct neuron synapses, all of that good stuff. I'm not a biology teacher. I'm totally blanking on the word for that. But you need those electrolytes to conduct nerve signals. And if you sweat out too much of it and don't replace it, those nerve signals can have problems traveling, and then you have all sorts of bad problems. So make sure you're drinking Gatorade if you're sweating a bunch. If you're outside in the summer, that's an important thing. So we talked about the non-electrolyte as covalent compounds. So hold on here, let me check. I believe this is the last slide. Yes. So saturation. A saturated solution is a solution that has the maximum amount of dissolved solids in it. So it means that it can't dissolve any more solids. So if you add any more solid, it will not dissolve. Unsaturated means that the solution can still hold more solute. So if you add more solute, it will dissolve until the solution becomes saturated. So here's an example. Let's say this is sugar. You're adding it to your tea. At first, let's say that there's no sugar down here. There's nothing in here. It's just you're adding the first spoonful of sugar. That first spoonful goes in and it completely dissolves. That means that the solution is not yet saturated. That means that it's unsaturated. It can still hold more sugar. Obviously, if you just keep on piling sugar in there, though, the water can only hold so much sugar, and at some point it becomes saturated. That's the point where it's got as much sugar as it can dissolve, and then any more sugar that you add from your spoon will just drop to the bottom because it can't dissolve anymore. So if you ever see any solids on the bottom like this and you try to dissolve them and they just don't dissolve, that's how you know that your solvent is saturated. It cannot hold any more solute. But if you continue adding sugar and it all dissolves, that means it's not saturated yet. So that's how you know the difference between saturated and unsaturated. Because you can't just dissolve an infinite amount of solid into a liquid. Eventually there's a point where it's what we say saturated. The word solubility, we talked about this already. The word soluble means it can be dissolved or it can't be. Solubility is another word you can use. It's a measure of how much solute is needed to reach saturation. So there is a way to quantify this. That's not something we're going to learn in this class, but I'm guessing if you move on into college chem, it is covered in that class. How much sugar? So there's a way to figure out how much sugar can fit in here, or how much salt, and you could say which one is more soluble. Can water hold more sugar or more salt? So there's ways to quantify that we're not going to get into. Just know that the word solubility just means how much solute can fit into the solvent before it becomes saturated. There we go, and that's all we have for this video. The next video, we are going to learn about concentration and how to quantify concentration. But before we do, you'll see there, I do have an example. So 35.9 grams of sodium will dissolve in 100 grams of water at 20 degrees Celsius. So you can quantify how much salt will fit in a given amount of water.